Hello everyone, Mr. Hissner here, and today we're going to be looking at some examples that are a little bit more involved, that are angle addition postulate questions. These questions will rely on us understanding the technical jargon, the content literacy, the definitions of the geometry that we are studying in order to have some to make inferences about these questions so that we can solve them. And yeah, so let's see what we have here. So our so our first question is it says we have some angles. We have angle WXZ. So again, I'm just gonna use green on the inside, WXZ, and I'm gonna do ZXY. So these two are my inside angles, and then this is the whole thing here is WXY. And so what we want to do here, we were told that WXY, so the whole angle here in blue is a right angle. So right away I know I'm going to have to use segment addition, right? So what I'm going to do here is just remind us that what we're going to do is add the measures. So these things are going to add together. Oh, that should be in pink. That's my bad. Measure of ZXY. And that's going to be equal to the one in blue, the measure of angle WXY. Okay, so in green, we have, this is going to be 5x plus 3 plus our one in pink, our angle in pink. So this is going to be 8x minus 4, and it's going to be equal to our angle in blue. Well, what's that measure? I don't know. How am I supposed to know? Oh, because it says it. It says that it's a right angle, and right angles are 90 degrees. Another way that we could write that would be this little box inside, right? Or we will have to be told that it's 90 degrees. Whenever we see that box, whenever we're told it's a right angle, then we must be able to conclude that this has to be 90 degrees, not 89.991 or 90.001. This is exactly 90 degrees. And so now we can go ahead and solve. So this is 5x plus 8x's. This is 13x's. Plus 3 minus 1 is minus 1. And that's equal to 90. And then what are we going to do? We're going to add 1 to both sides, just so I know these are canceling. And so we have 13x is equal to 91. And again, we all know our 13's times tables. So we do know that this is 7 without having to, but if you don't know it, that's okay. So what we can do is divide both sides by 13, and we know that x is 7. And again here, kind of typical with these problems is we want to find the measure of this angle in green and then find the measure of this angle in blue. So just note that this is the angle in green and this is the angle in pink. My mistake, pink. And so what we're going to have to do is use our x value to substitute this back in. So we know that our green angle was, is the measure of angle WXZ, and that is equal to 5 times some number plus 3. And then our pink angle was, the measure of the pink one is ZXY, and this is 8 times some number minus 4, and we found our number to be 7. And so 5 times 7 plus 3, that is 38. And 8 times 7 minus 4, that is 52. And these things are degrees. Okay, let's look at another example that may be tricky. So here we had to use the property of the right angle. But once we figured out that the right angle was 90, it's just, again, just kind of rinse and repeat here. Combine like terms. Look to combine like terms if you can. Balance the equation, so x's are on one side, numbers are on the other. Divide by the leading coefficient on x. Use that x value, plug it back in to find our values here, right? And so this is a very simple process. What we had to do here was know what a right angle was and use that to get our x value. So what I'm going to do here is look at this one down here. And this says that if we have a bisector. So if QS is a bisector, so what's going on here? So QS is a bisector of angle PQ PQT. So this angle is being bisected. And what happens when an angle is bisected is that the measures on either side of the bisector are the same. That those two angles are congruent. And I'm going to mark that. I'm going to mark that here. These two angles are congruent. They're the same, right? So then we're told that angle SQT. So SQT, let me make this smaller. Angle SQT is 8x minus 25, and then angle PTQ, so the whole angle in green here, PTQ already had that. So this whole angle in green is 9x plus that 34, and then SQR, so then this angle, SQR, it's kind of like this whole thing in yellow there. Maybe I'll just highlight it. I'll just write it in yellow. I can't. How about that? SQR is 112. And then we want to find each. But what I really want to do is show us how we can use that angle bisector to make a conclusion. So what do we want to do? Let's see. We have SQT. And this is 8x minus 25. And so if SQT is 8x minus 25, right, and these two are the same, then that means that PQS is also 8x minus 25. Okay, and that means that we can set up an equation. Now let's look to see what equation we can set up. We have the measure of angle PQS, that is this angle over here, right? And we have the angle of the measure of angle SQT, and it's equal to the entire angle here in green. So this is equal to the measure of angle PQT. And so look, these two things are the same, right? This one is 8x minus 25, plus this one is 8x minus 25. And what's it equal to? Well, it's equal to the whole thing here that we had in green. This is 9x plus 34. And so really, this question is not as bad as it looks. I mean, there is a lot going on here, and we're asked to do a lot, but this is just like recognizing the midpoint and its influence, its effect on the values that we have as a result of that midpoint. Midpoints and bisectors are very similar, as to a midpoint divides a segment in half and a bisector divides an angle in half. So let's look at what we have here. Just combining some like terms. And then let's add 50 to both sides. So these two will cancel, and let's subtract 9x from both sides. And so I'm just going to keep working down here. So we have 16 minus 9 x's is 7 x's, and this is 84. Oh, I recognize that. That is 12 times 7. Of course, we can divide both sides by 7 to find that. And so we have x is equal to 12. And then to get these values, what we'll have to do is use x, plug them back in, right? And then we can do some subtraction to find this last one. But that's the idea here, is that we need to use the verbiage, use the language of geometry to make conclusions about the values and the figures that are presented to us. This one was key in that you needed to know that a bisector makes two angles the same measure. It makes two angles congruent, and thus you can add those measures together to get the whole thing. And really, you're just going to be doubling that value, and that's exactly what we did here. So hopefully you found this helpful and insightful. Thanks for watching.